everybody. Now we're going to continue on by talking about hurricanes, tropical cyclones, typhoons, and all that kind of stuff. We're going to take that whole trade winds and tropical waves and talk about what actually happens to those. So this is the more interesting stuff. So, first off, what is a hurricane? Well, hurricanes are actually the largest scale single extreme weather event in that tornadoes may only span a couple of miles. Thunderstorms may only span maybe a city or two. Other events are usually much more localized, whereas hurricanes can actually span hundreds, if not in some cases, thousands of miles in diameter. So they can span over a gigantic area. Now, hurricanes are tropical systems. What that means is they need a lot of heat. As a result, they don't form in the winter. Winter is not a good time for them. So here in the northern hemisphere, specifically in the Atlantic, because that's usually where all of the hurricanes that affect the US come from, they typically occur from June to November. We call this hurricane season. Now, there's no set rule that says that a hurricane can't form before or after this season, but for the most part, this is what we refer to as hurricane season. We usually don't expect development before or after. It usually is constrained to the season, but it can still happen. Now, hurricanes typically move from south to north and from east to west. And this has a lot to do with two things. One, the trade winds, because the trade winds blow from east to west. Two, in addition to the trade winds, we also have those subtropical high pressure systems at 30 degrees north. Most hurricanes actually ride along those subtropical high pressure systems. And so what they do is they usually develop beneath them. They develop equatorward from them, and then they ride along them, moving north towards the poles. And this is actually very important because hurricanes actually act as a method of heat and energy transfer. They actually transfer a lot of heat and energy from the equator to the poles. So in a real sense, hurricanes are just one of Mother Nature's attempts at evening out the temperatures here on Earth. Now, hurricanes need three things to form. They need warm ocean waters. They need low wind shear. Wind shear can basically shear the top off, can basically give the hurricane a buzz cut, weakening it. And they need moist air. If those three things are in place, a hurricane can develop rapidly. Now, before I continue on, people have commonly asked me, are hurricanes, typhoons, cyclones, are they the same thing? Or are they different? What's different about them? And the fact is, there's nothing different about them. They're just different names given by different regions. We call them hurricanes here in the United States. But actually, in the Western Pacific, areas near Asia, Japan, China, the Philippines, and so on, they call them typhoons. Meanwhile, countries in the Indian Ocean basin call them cyclones, as well as countries near Australia in the southern hemisphere also call them cyclones. So, and there are other names for them as well. I've even heard the term willy willy used to describe them. Now, I don't know who came up with that, but there have been many terms used to describe hurricanes. How do hurricanes develop? Well, they start off with those tropical waves we talked about last time. Tropical waves are very weak areas of slightly lower than average pressure. Lower pressure promotes lifting air. There's a little bit of convergence that occurs near low pressure. Now, if the conditions are right, if the water's warm enough, and if there's enough energy feeding into the storm, that low pressure can intensify. As it intensifies, it evolves from a wave-like structure into a more circular cyclonic structure. Once it's done that, we say that it's organized, and we call it a tropical cyclone at that point. Now, there are 3 types of tropical cyclones, and these represent different life stages for a tropical cyclone. All tropical cyclones will go through at least some combination of these. The first one is called tropical depressions. Tropical depressions are, as I was told when I was a kid, they're like a wannabe hurricane. Basically, they're weak, they're very unorganized, they don't have all the cyclonic features yet, but they have begun to get their act together. If the wind speed is below 39 miles per hour, we call it a tropical depression. At this point, we start keeping an eye on it. We assign it a number, not a name yet. We assign it a number, and we begin to monitor it. We begin to issue forecasts for it, make predictions for it. If there are people in the path of it, we might warn them. But if a tropical depression hits your region, unless it stalls and dumps rain on you for days, it's not really going to cause a lot of damage. So we usually don't worry too much about them. However, if they stay over that warm water, if the air stays moist, and if there's no wind shear, they can continue to grow. As they grow, that low pressure deepens and the wind speeds increase. Once the wind speed gets above 39 miles per hour, it becomes what we call a tropical storm. Now, a tropical storm is actually something that we name. So here is where the name Alice comes in, or the name Charlie comes in, or Katrina, or Andrew, or Hugo, or any of those major storms that you've heard about before. That's where they come. That's where that name comes in, when it becomes a tropical storm. As it becomes a tropical storm, it's getting its act together more and more. It's developing more cyclonic motion. It's beginning to look more and more organized, but it's not quite there yet. Again, if a tropical storm hits your region, the winds can be strong enough to cause some minor damage, but again, mostly rain's going to be the concern. However, if that storm stays over the ocean and has more time to get its act together, it can then strengthen into a hurricane. And hurricanes are very strong. And at this point, wind speeds are actually at a point where they can do some damage. And the lower end of hurricanes, what are called minimal hurricanes, can do minor damage. And then as the hurricane strengthens, if it becomes something called a major hurricane, it could do very catastrophic damage. Now, we're going to talk primarily about hurricanes here. But I do want to mention that all hurricanes start out as a tropical depression, evolve into a tropical storm, and then strengthen into a hurricane. Now, once this hurricane loses one of those 3 things that we talked about, if it loses that moist air, if it enters a dry layer of air, or if it hits land and it's no longer over the ocean, or if it moves over cold waters, or if wind shear hits it and begins to weaken it, it can actually move back down to these other 2. And that's the process of it weakening. So it starts out as a weak storm, strengthens, but then eventually it weakens again and goes away, which is a good thing. It'd be dreadful if a storm like Katrina was permanent. It just stayed and it just kept causing damage. So it's a good thing that once these storms lose their food, they begin to weaken. This is an image showing different stages of different development. If you take a look here, you'll notice that these tropical depressions and tropical storms aren't nearly as organized as the hurricanes on this image. If you take a look, these tropical storms, you don't see a very tightly packed cyclone. There is circular motion going on, but it's very weak circular motion. Whereas hurricanes have a much more spiraled-like structure to them. They almost look like buzzsaws in a way. So that's how hurricanes look like. And so the stronger the storm gets, the more organized it gets. And actually, as it intensifies, as it gets stronger, something interesting happens in the center of it. What actually happens is something called an eye develops. Basically, it's a hole in the clouds in the middle of the storm, and we'll talk about some interesting things about this eye in a moment. And there are a few reasons why this eye occurs, partially because of upper level divergence, which causes sinking air around the eye, and then you also have rising air in the center of the eye, and so there's just this calm area in the center of the storm. With that said, all hurricanes are made up of a few different components. You have what are called rain bands, the eye wall, and the eye itself. Rain bands are these bands of showers that wrap around the storm. And as you approach these rain bands, they begin to get more and more intense, stronger. Winds become stronger, the rain becomes heavier as you move closer towards the center of the storm. So the outside rain bands are weak, there's a little bit of wind, they're not very heavy, but the closer you get to the center of the storm, the stronger these winds become and the heavier this rain becomes. Eventually, there's one area where you hit this rain band right near the center. And in this rain band, the winds are the strongest, the storms are the strongest, and the storm is the most intense. This is what's called the eye wall. It's the center of really intense storms that wrap around the eye itself. And this is where the strongest winds in the hurricane are located. So it's this eye wall that's capable of doing the most damage and destruction. Once you get into the center of the storm, something ironic actually happens. In the center of the storm, the sky clears, the winds calm, and rain stops falling. This is what we call the eye of the storm. Here, it's calm. Now think of this. Let's say a hurricane was approaching our area. You took all the necessary precautions, you bunkered down, and you had 3 or 4 hours of howling winds and heavy rain. And then suddenly, the sky cleared up, and the rain stopped falling, and the wind stopped. What would you think? You would probably think, hey, the storm's over. And a lot of people actually do that. They think, hey, the storm's over, they get out of their shelter, and they start cleaning up. 15 minutes later, the eye passes, and they get encountered with the other end of the eye wall, the other strong part of the storm. Many deaths have actually been attributed to that. People thinking, hey, the storm's over. A good trick, though, if you want to know, is this the eye or is this the end of the storm, is to have a barometer on hand. The reason why is because the eye of the storm represents the lowest pressure of the storm. Now, if you recall from previous lectures, the average sea level pressure outside is approximately 1,013.25 millibars. And to be honest, unless you're in a really intense storm system, it usually doesn't go much lower than 1,000, and it usually doesn't go much higher than 1,030. So we have a pretty narrow range of average air pressures. However, in the center of a hurricane, air pressures can get as low as 950 millibars, 940, 930, and in fact, in some hurricanes, such as Hurricane Wilma, one of the strongest hurricanes on record, air pressure actually went below 900 millibars. So if you're in a hurricane and you see what looks like calm skies, take a look at your barometer. If it's nowhere near 1,013.25 millibars, then bad news, you are not in the clear yet. Instead, you're in the eye. Now, if you're like me, being in the eye is kind of on my bucket list. I'd run out, take a hashtag selfie, enjoy it, and then run back in. And just really quickly, just for safety's sake, this is in millibars, but if you want to know the average pressure in inches of mercury, it would be 29.92. And this is also something that you would probably see on a barometer. And so if it's much lower, and I'm talking like 29.00 or 28 point something, that's when you know, okay, I'm still in the eye. If it's not near 29.92, then chances are you're in the eye. So this is just a diagram showing you how pressure changes as you go from the exterior of the storm to the interior of the storm, to the center of the storm, and it also shows you how wind speeds react as well. Pressure starts out high, and it quickly drops once you get into the center of the storm. On the other hand, winds start low, they peak near the eye wall, and then as soon as the eye hits, they drop off to almost nothing. So in the eye itself, low pressure, low winds. Now, in the last module, we did a little bit of work on tornadoes, and we talked a little bit about how tornadoes cause damage, and more so how the direction and the wind speed of a tornado can greatly influence who gets the most damage. Well, this same thing also applies with hurricanes. A hurricane here in the northern hemisphere rotates counterclockwise. And so the winds in the hurricane are rotating counterclockwise. If those winds are blowing in the same direction, let me get my cursor here, like over here, if they're blowing in the same direction that the hurricane is traveling in, you get intense wind speeds. If they're blowing in the opposite direction, you get substantially lower wind speeds. And just like in a tornado, it's basically the exact same concept. I'm not going to have you guys do an activity on it this week, but it's basically just the same concept. Now, as I mentioned earlier, hurricanes are tropical systems. As a result, they form in the summertime. But when in the summertime are they the most common? Well, you would think, okay, maybe the hottest months, July and August. Well, believe it or not, September is actually the prime season for hurricanes. And the reason why is because those waters that the hurricanes form under have been heating up all summer long. Even though the sun is beginning to travel back south, even though we're beginning to transition into fall, that water is still gaining surplus heat every day. It's almost like what happens if you leave your pizza in the oven even after you've turned the oven off. Your pizza will continue to heat up. Well, the same thing happens with water. It continues to heat up. And so, believe it or not, hurricanes actually usually are most common in the late summer and early fall months. And then there's a slight extra peak here in October, and meteorologists are still trying to understand why this is. But the main peak is in September. And if you take a look elsewhere in the hurricane season, hurricanes and tropical storms just aren't as common. They're just not as common. So, I mentioned this previously, but I'm just going to say it again real quick. Hurricanes start near the equator. They actually don't form on the equator. They start near the equator, but they don't form on the equator. They don't form on the equator because there's no Coriolis force on the equator. No Coriolis force means no cyclonic motion. No cyclonic motion means no hurricanes. But they form close to the equator where the waters are warm and the wind shear is usually very weak. Then they travel, as this diagram is showing, they travel from east to west, and then as they make it to the other end of the ocean basin, they get caught up in what's called a mid-latitude high-pressure system, like this one here, in the middle of the Pacific. And this high-pressure system actually rotates clockwise. So on one side of the Pacific, they just move from east to west. But as they approach the other side of the Pacific, they get caught up in this western end of the high pressure, and that causes them to curve to the north and then back out to sea. And you actually see the same phenomenon in every ocean basin. And the same thing also happens in the southern Pacific. Now, if these hurricanes still make it close enough to land before they curve, they can still hit land and cause tremendous damage. So, even though many of them just curve out to sea, there are those few that don't. The last thing I'll talk about in this particular lecture is how we rate hurricanes. When we talked about tornadoes, we talked a little bit about what's called the Fujita scale. It's a scale created by a gentleman named Ted Fujita. Well, hurricanes actually have a very similar scale. It was created by two scientists whose names are Saffir and Simpson. No, not Homer Simpson. No, not O.J. Simpson. No, not Bart Simpson. I actually don't know what their first names are. I'm sure I could look it up on Wikipedia if I wanted to, or look it up somewhere. But hurricanes are rated on a category from 1 to 5. Category 1 and 2 hurricanes are what we call minimal hurricanes, in that these type of hurricanes are hurricanes that are going to cause some minor structural damage, maybe some shingles will be blown off a roof, maybe some broken windows, but really other than that, most well-built structures are going to stay put. People are going to be pretty safe. If they bunker down, they're going to be okay. The only exception to this is if you live right near the ocean. If you live right near the ocean, you're prone to something what's called storm surge. We'll talk about that in the next lecture. However, as the hurricane intensifies, it then transitions into what we call a major hurricane. A major hurricane is anything category 3 or higher. Make sure you write that down. A major hurricane, anything category 3 or higher. These kind of hurricanes are the ones that people evacuate from. A category 1 or 2, basically what they're going to tell you to do is get some emergency supplies, board up your windows, and just ride it out. They don't want you to evacuate in those cases because they don't want you to clog up the roads, because people near the ocean do need to evacuate. However, in the case of a 3, 4, or 5, no, they want everybody out. They want as many people away as possible, even if you're further inland, because structures are going to be much more compromised in these kind of storm systems. So 1s and 2s are minimal hurricanes. They basically are just ride it out kind of storms. 3s, 4s, and 5s are major hurricanes. These are the kind that, nope, you don't want to ride that out. You want to get away from it. I mentioned earlier that someday I'd love to experience the eye of a hurricane. I'm hoping to get myself into a nice category 2 so I can bunker down easily, not worry about the roof flying off my house, but who knows, we'll see if that ever happens. So, one last question before I end this lecture. Why don't we here in California get hurricanes? Well, there's one easy answer to this. If you've ever been to one of our beaches, so if you've ever gone to Santa Cruz, Half Moon Bay, Ocean Beach, Monterey, or even down in Southern California, Santa Barbara, Ventura, Santa Monica, the waters are pretty cold. Well, because the waters are pretty cold, because the waters are pretty cold, we don't get them here. And the reason why the waters are pretty cold is because we're next to what's called an eastern boundary current that carries cold water from the poles down to the equator. So that's why we don't get hurricanes here, which is a good thing. Now, next time we're going to talk a little bit about the damage hurricanes cause, and then we're also going to talk about what's in a name. What causes hurricanes to be named, or how do they get their names? Until then, I'm Terrence Mullen.